Welcome, everyone. Hi, I'm Kanch. I'm one of the hosts of the 5 Days of AI Agents intensive course. I'm here with Anand Navalgria. Anand, why don't you say hi?
Hi, everyone. I'm a co-host with Kanchi and the founder of this course, and I'm looking forward to walk you through the rest of day 5 today, the final session.
Thanks, Anand. So, today, the finale of the 5 Days of AI Agents intensive course. This has been an amazing journey. We have seen all of your incredible questions, feedback, insights over across all of the social platforms. We sincerely appreciate it. This is a village, and as we mentioned earlier, it took nearly 100 plus volunteers working over several months to bring this to life. I especially would like to call out the leads that worked tirelessly over the last few months. Kinjal Parak, I don't know if we would have done anything without you for your efforts in marketing and getting us all up to the stage. Brenda Flynn, the force of reason and sometimes hard decisions, and also program managing the whole effort. Ho Long Lin, lead on code labs to make sure all the nuts and bolts are well placed. So it has been seamless experience for you all. Anand, the founder and leader of this effort, and sometimes giving us surprises all over the place. It has been an amazing journey. I would be remiss of not calling out Sarah Wally for the run of the show logistics and ensuring the seamless flow. And last but not the least, Ray Harvey for all of program management efforts across the board, white papers, code labs, and communications. Thank you, thank you, thank you.
I,
By
I,
this
I would
time, you
like to,
already are aware of the intensive work and the things which have been put in place. As a reminder, and some of the questions have popped up that would the course be available offline after the session? Yes, it will be available through the same channels as we discussed above, and it is definitely been amazing for us to be able to do this program. Anand, do you have anything to add?
yes, thank you, Yoz. Thanks for the intro. And yes, looking forward. Hopefully, you've gone through all of these things in the program. I would also like to give a shout out to all our sponsors, including Alison Wagenfeld, Ricky Robinet, Will Granis, Saurabh Tiwari, Brian Delahunty, Michael Collig, and all the others who sponsored and supported us, even if we haven't mentioned all the names. But thank you so much, everyone.
Thank you. And this moderators have been with you over the journey for the last 5 days. Special call out to Brenda in keeping all of us on check and making sure it's funnel, like the channel communication is transferred across. Thank you. Thank you so much. So we are, as we mentioned earlier, there is a lot we can discuss about AI agents. We designed this course especially in mind of how you can get started, get active, immediate agent building skills. And we are in day 5 going to discuss about production. Anand, why don't you just join and share the curriculum review for day 5?
Perfect. Thanks, Kanch. So, everyone, glad that you've made it this far. Here is where we talk about prototype to production. Over the last 4 days, we have designed sophisticated agents with tools and memory, and then learn how to rigorously evaluate them. Now we face the final hurdle, bridging the gap from a local prototype that you built in your labs, in your Kaggle code labs, to building a secure production system. And day 5's paper, Prototype to Production, as well as the corresponding code labs, is your operational playbook for bridging this massive last mile gap where 80% of the real work often lies. So the white paper, it starts with people and process, defining the specialized roles needed for mature agent ops, from AI engineers designing guardrails to platform teams managing authentication and authorization. A core theme in this white paper, in this section, is the evaluation gated CI/CD pipeline. And I recommend diving deeper into that section. It's very interesting, in my opinion. It's simple but powerful. No agent version should ever reach production without automatically passing a rigorous evaluation suite that proves its quality and safety. We covered safe rollout strategies like canary deployments, starting with, say, 1% of users, and blue-green deployments to minimize blast radius and allow instant rollbacks if something goes awry. Once live, you need a continuous observe, act, evolve loop using real-time monitoring to trigger immediate fixes, like, say, or circuit breaker works, but instead in this context for a failing tool, and then feeding insights back into the development for long-term improvements. The paper concludes by looking at scaling beyond single agents using the agent-to-agent, or A2A as we call it, protocol to build collaborative ecosystems where agents can discover specialized peers and delicate complex goals. So that would be it for the summary of the white paper. For those of you who haven't had the opportunity to read it completely, I would recommend starting off with the summary Notebook LM generated podcast. And then if you feel like it, load that paper up in Notebook LM and ask it questions, use the mind map to navigate it, as well as get your own video and audio overviews to interactively interact and read the white paper. All right, Kanch, then give it over to you to the exciting Q&A session.
Thank you, Anand. And one of the things about this paper is also it's very short. So it's easy for you to be able to grasp as well. So looking forward to having you place reviews. So now on to the meat of the section with the Q&A. Can we have Will Granis, Socrates Katakis, Elia Seshi, and Saurabh Tiwari on stage, please? Thank you, everyone. Thank you for joining, despite your busy schedules in answering questions with the community. Community definitely enjoys it. We see that in the live chat. We see the interactions going on, and they appreciate you being here. So thank you so much for being here for us. Would you like to do a quick introduction? Why don't we start with Elia? You are on my screen first.
Thanks, Kanch. Nice to meet you all who are watching this. I'm Helia. I'm a ML specialist in Cloud AI, looking at helping developers, customers, bringing agents to production.
And one of the white paper authors.
And one of the white paper authors, yeah.
And do try out his agent starter pack, which is very useful as well.
I'm sure you would do the branding soon. Thank you. Will, you are on my screen next.
All right. Well, honored to be in your screen. Hi, I'm Will, and I'm the CTO here at Google Cloud, and super excited to be a part of day 5 of this agent intensive. And a big shout out to everybody who put this program together. Amazing stuff. Honored to be here.
Thank you so much, Will. Appreciate it. Saurabh?
Yeah, hi everyone. Super excited to be here, and thank you to all our viewers who are watching it. It's an amazing journey that we are working together with you. I lead the Cloud AI organization, which includes Vertex, Collab, Kaggle, and a few other businesses. By the way, one quick shout out that I'm also a follower of this course because my kids are trying to follow along. So I'm following up as well.
We love it. So we would have candid feedback.
Yes.
They're getting expert advice. That's no fair.
Yes.
Great.
We have an insider track.
Right.
Awesome.
Socrates?
Hello, everyone. I'm a Gen AI black belt for Google Cloud. I help enterprise customers to bring some hundreds of agents into production. And this is my love, Agent Ops, ML Ops, and the whole area of Ops. And I'm happy to help you today.
And one of the authors of the white paper.
And also the previous two courses.
Thank you. Thank you for everyone for being here. And definitely in the live stream, we see it, and on demand after too. There are close to like 200K folks in Discord who are continuously asking questions. So we are excited to see what we do here today. Anand, why don't you take this first?
Thanks, Kanch. Excited to ask Saurabh this question for you. So going forward, what do you think is more important for models, deeper reasoning capabilities or the extreme token efficiency and speed required to make real-time multi-agent meshes commercially viable?
No, I think this is an excellent question. I think at a high level, I would say it depends, depending upon the application. If you look at from a reasoning perspective, from a core model reasoning perspective, the reasoning needs to be very strong for the models to make choices during the agentic application as to what tools to use, how to act when they are seeing responses which have uncertain outcomes, how to decide which path to navigate, etc. So core reasoning is important. In many applications, if we don't have fast enough latency, it may not be viable or like practically viable, because you may not want to, as a user, wait for a very, very long time, which is there. So I would say it is a trade-off as we go along. Let me provide some color from where the research is heading. What is happening is that as foundation models are improving, a lot of the reasoning is becoming a lot thinner, because much of the logic is being processed by the model itself internally within its own systems. So what you should see as we go forward is that the number of reasoning tokens which are getting produced will become smaller for the same type of task. Now, what that provides us is that we can now then use the model for much more complicated tasks. So you can have, instead of creating a mesh of like 3 agents working together, you can now have 5, 15, 50. Our ambitions over here are pretty high. We do see a world where agents will be able to work across like multiple very complicated structures as we go along. One other thing from a practitioner's perspective I would call out is that when we are building agents, it is good to simplify the task of a particular agent so that it becomes, so the reasoning becomes a lot more easier. So you can, if you can break down the task into multiple sub agents, which can all orchestrate amongst each other instead of one giant prompt and one single super agent which tries to do everything, that will help both with latency as well as with quality.
Amazing insight. Thanks, Saurabh. And I find it fascinating that just some time ago, reasoning wasn't there in the models at all. And now we had reasoning, long traces, and now we're going back full circle to minimizing reasoning. So life goes full circle, and so do agents, it seems.
And the agents, sub-agents is interesting because in the day one of the question was, what if I had agent with 50 tools? That was the question which was out there.
Yeah, actually, if you look at in commercial systems, what we are observing is many of the developers who are building their agents, they start with 1 or 2 as a toy example, but very soon as these agents start performing the job that they are expecting, the expectations rise, and then people start throwing more and more tools at it, and it becomes basically a reasoning challenge as if you go into like 50 or 100 tools, and that's where like having some level of like hierarchy or some subdivision will be helpful.
And if I may, we need to treat the sub-agents and multi-agent systems as microservices, right? The same reason that we build microservices is this, to reduce the problem into the minimum effort, let's say.
Yeah, but I believe the statelessness part might not be necessarily true for agents. You might need to share the state, but other than that, yes, definitely with modular design. Amazing. Thank you. Thanks for the interesting conversation, everyone. All right, shall we move on to the next question, Kanch? So this one is for you, Bill. What is the biggest gap you currently see in the industry's tooling for productionizing agents at scale? Additionally, in your opinion, how should it be addressed?
Sure. So one of the principles that's actually covered in this week's Agent Intensive is using evals as a quality gate before you move agents into production. And I think it's fair to state that the state of our tooling today is that humans are the deployment gate for agents. So where I see things heading is a world where we have so many agents being built, as that confidence builds that Saurabh was talking about inside of organizations and across development teams everywhere, more and more agents need to get into production. They're going to be acting in parallel. You're even going to have agents writing code on the fly to include other agents. It's going to be super difficult for human-centered and human-gated evals to keep up. So the tooling I see emerging from this really centers on this kind of continuous agentic evaluation. How's it going to take shape? Well, let's see. I think you have to think about this in terms of the organization itself. So in any reasonably sized organization, about 80% of the use cases or applications for agents are going to be kind of moderate to low risk. They're going to be internal processes, going to be things that aren't necessarily in full view of users. So, I see a world where agentic evaluations can leverage the observability and trust primitives that, Sarab and the team have built into our cloud and AI platforms today. You can have those, and then you have the simulation and offline agent improvement, mechanism, and the net of all that is the development of AI evaluators. And AI evaluators are going to move these lower risk agents into production more quickly and autonomously. It's going to give everyone a lot more confidence, and it's going to speed up the big task queue and agent queue that's headed for evals. But the best part is that the most complicated and risky deployments, which are going to be the focus, for the CTOs, the CIOs, the CISOs, and the leadership of these organizations, they get to be evaluated by engineers because they have the time to really dig in and look at these more complex or maybe potentially more risky agents. And so the primitives for this architecture that I referred to, they're already put in place in Google's cloud and agent platforms. Things like Cloud Trace and Sessions. This is going to allow all of you to pre-train these eval agents, and you can use either real or simulated agentic behaviors. And then you combine all of this with the manual and automated feedback loops, and you're really going to be able to build these AI evaluators that are much more and more capable over time. And that's going to enable the scale that's of adoption and the climbing of the value curve inside of these organizations. And it's going to also partition the tasks that we give to agents, partition the agents themselves along risk and use case specific boundaries, which is really an implementation concern for every leader in every organization right now deploying agents.
Yeah,
Amazing.
and one other thing I would add, completely agree with Will on the points that he made, is that particularly within teams, groups of either small teams or larger teams or organizations, what is happening is as different people are building agents, there is also this level of kind of like the Play Store analogy of which agent should I go trust, because that is made of high enough quality that I can use as either as a building block or as a standalone agent for my task. So this agent management review process, some level of quality gates, etc., that is becoming more and more common. Another thing that we are seeing is that there's this notion of an agent marketplace where people can publish agents, and then either you can modify them or you can use them as is. But again, the level of trust, etc., starts coming into picture. And we do have some efforts relating to agent marketplace within Vertex as well.
Yeah, and these reputation mechanisms, because that's really the currency of trust, over time in these organizations is, both the people that are developing them, but also, just this history of agent development. And it goes beyond, I think a lot of the metrics today are around quality and, kind of performance or efficiency. But there's also going to be these new metrics that emerge around, consistency and around actually staying in alignment with policies, especially over long task duration. And as Sarah was mentioning earlier, as you have these multi-agent systems, it's much more complex.
Yeah, one other thing which is about security. As you start putting, Will was mentioning, right? As you start putting things into production, security becomes a big challenge, because you can have fairly sophisticated attacks which could be structured around agents. An agent can do all the tasks that it is expected to do, but then it can do some additional things which it is not expected to do. So there is also when an agent is deployed, right? How do you monitor it, right? And how do you give it accreditation? What kind of identity it should use so that we can retrace the steps back. There is also some requests for, should we have an undo step as part of the agent, so that we can retrace some of the step or the previous state management kind of a thing. For example, in your collab notebook, I know there is a reset all kind of an option that is there in the notebook instructions, the factory reset button, something along those lines. These are all things that seem to be important as our agents become proliferated into the industry as well as in other places.
And in terms
Oh,
of
that-
security, a very important also topic is how you can implement the authentication authorization hopping. What I mean by that, you have an agent, you authorize this agent to use your credentials to do whatever you want, and then this agent needs to call another agent. This agent needs to call another agent. How do you pass this to all these agents?
Yes.
Definitely. Wow, I think that answer summarized pretty like a lot of the topics for all of our 5 days. Authorizations to agent evals to it reminds me of the movie Inception, agent evaluating other agents, which then in turn need to be evaluated, and all the great security as well. Amazing. Thank you, everyone. That was very insightful. Awesome. Kanch, shall we move on to the next question? So this is for both of you, Saurabh and Will. So as enterprises struggle with decades of legacy IT, do you see agentic interfaces via protocols such as A2A becoming the de facto standard for modernizing these legacy systems? Or is that, in your opinion, just adding more technical depth which somebody needs to manage?
Well, I mean, for me, the short answer is yes and yes. Yes, agentic interfaces and architectures are going to become the standard for modernization. And yes, there will also be some tech debt that comes with it, but it isn't necessarily a terrible thing. We'll talk more about that in a bit. But just think about the sheer velocity and scale that agentic workflows are enabling. It's going to completely transform how organizations think about delivering internal services and their external customer experiences. I mean, it's already happening. I work with a health system right now that's using agents built on Agent Development Kit. And this is cascaded out to over 30,000 workers, and it gives all of them immediate access to all of the policies in their organization without them having to do a bunch of like searches over a bunch of internal sites or deal with like slow keyword matching chatbots. So like even in highly regulated industries, organizations are already taking this existing architecture that they have in their business processes. They're kind of like breaking them apart and they're recomposing them into these agent-based workflows. And as the ROI continues to increase, it's just going to encourage more and more of this and more of the existing applications, data stores, and systems to be available to agentic workflows. And ironically, the tech debt that's being built is going to be increasingly burned down in parallel by agents that can execute tasks like code reviews, bug fixing, and the like. So we have a way out of the tech debt possibly for the first time as these agentic systems improve. And I do want to mention one other protocol, which I'm really excited about right now, and this is the Agent Payments Protocol. If you think about the modern web, the foundations are basically a set of standards and protocols that enable high-speed, reliable communication. But it wasn't until the web became the vehicle for commerce and supported value exchange and payments that it really flourished. And it is the vehicle for digital transformation today of every industry. I think you're going to see the same arc with agents. You can imagine how enabling an agent to retrieve items from shops for you based on parameters you provide can make shopping, it's better for you and it's better for the merchant. It's way more efficient and it's going to make your everyday life it's like a superpower operating in parallel to get things done. And I also think it's going to be true that business to business transactions are going to be completely reshaped by agents communicating, negotiating, transacting, verifying, even representing suppliers and ecosystems. So the value is going to be really compelling. And now the programming model, thanks to Saurabh and the team, is natural language. It's going to bring more people into the innovation process. And you're going to end up on this kind of multi-party, multi-agent commerce engine at web scale. And that's going to build upon this agent to agent. Step one, you got to be able to build the agents, ADK. Step two, you need to enable multi-agent, interaction policies. But the long game is enabling value transaction to happen, across multiple agents, whether it's within a firm or multiple firms coordinating. And I think that's where you're going to see, this breakthrough, this transformation.
Yeah, no, completely agree with Will on his yes and yes to the question. If you think about enterprise IT systems, one of the challenges that and why the systems are where they are and some of the challenges is because the level of investment is not that heavy because very small teams have to manage a variety of different applications and they can only do so much in any of these areas, right? And that's why some of the tech debt, etc., starts getting accumulated. One, I would say if you look on the positive side, because of the coding capabilities that the models have and some of these agentic systems have, we actually, what I'm expecting is much more better IT systems, like from the ground up itself. that may come up, because you are basically now having extremely sophisticated like software engineers building like code independent of whatever is the application, and you are not making a choice based on like the return on investment or how. And that's the big promise of AI, right? That it kind of democratizes like quality code across the board, right? That's just one aspect of it. The other thing which these agents are offering is that within the computer use paradigm, even if you have traditional enterprise systems, which with their UI being a lot more clunkier, etc., right, and hard to use, and only the subject matter experts know which button to click after which one in what order, etc., and so on. With computer use, the agents can actually create reasonable encapsulations on top of these, so that the ramp up time for using some of these traditional enterprise applications could be a lot easier. And I'm talking about, obviously, there are the SaaS providers, but also there are when I'm talking about enterprise applications, the applications provided by SaaS providers, but also in-house built kind of like applications, right? So you could have interfaces on top of pre-existing applications, which can make them easier to use and interact, and with higher enough quality, so that the brittleness between, particularly when you are chaining together multiple applications, that brittleness kind of improves quite a bit, right? Now, due to this, yeah, go ahead.
So I was also going to say, so, to your point around legacy systems, one of the really emergent behaviors we see is AI and agentic workflows being able to understand legacy code bases or proprietary code bases that are specific to an organization, being able to reason about how to potentially refactor, or to Socrates' point earlier, like how should we go about the dependency mapping and kind of breaking apart some of these larger monoliths and breaking them into microservices. That's another emergent behavior that's really exciting.
Yes. And so one other thing was that one challenge on the whether it is going to add technical debt is because of the stochastic nature of these agents, we need to design them in the right way, and that's where, even from a thinking perspective, when we were doing, I think in the lab 2, we were doing the currency conversion agent, etc. If you play around, you need to be careful with how you construct these agents so that they are not probabilistic, because then we are passing on that responsibility of correctness onto the user rather than on the agent. And so the design, etc., the earlier conversation that Will was talking about like evaluation systems and agents evaluating other agents, etc., becomes really crucial, because you don't want just a mesh of agents where each one of them worked in a particular demo and you just connected the whole thing together and you hope that it continues working. So we need to be more principled relating to that as well.
Amazing. That was a great overview on a lot of my favorite topics, like code modernization using agents. Personally working on one project like this, really exciting. To computer use, to connecting workflows and evaluating them end to end. I think there's a lot of excitement in store, even though it's day 5 for us. But hopefully, amazing answer. Thank you, Saurabh and Will. Really, Kanch, would you like to move over to the community questions now?
Sure. I love that, Saurabh, you were actively testing the codelabs. And thankfully, we didn't know this before. I think we would have been even more, tensed about it.
Next time we should enroll you as a tester, a very unbiased tester.
Unbiased tester, but I didn't know that before this call. So I'm super happy that we didn't know about it. So thank you. So now, with respect to the community question, particularly these came from the community Discord channels, and this is from the Discord user Ottil Lastry. For Elia and Socrates, what is the recommended security model for cross-boundary untrusted third-party A2A calls, considering that A2A lacks built-in authentication or zero trust mechanisms? Elia, why don't you go first?
Actually, Socrates prepared.
Yes, sounds
work
good.
specifically.
Socrates.
Let me start, and then I'll complement.
Okay, so first of all, I want to start with the word untrusted, right? I am not going to use any agent in my systems if I haven't tested the agent, if I haven't passed through the security review, if I haven't evaluated the agent and generate the performance review and metrics that I want, right? It is like you open the door to an unknown person to your place, right? And you say, get my personal card and do my purchases. You cannot do that, right? Even in agent payment protocol that Will mentioned earlier, what we have introduced there is the notion of mandates with verifiable digital credentials that actually the user needs to sign like a document to say, yes, I approve this to move on. And then AP2 or agent payment protocol is built on top of A2A. I need to say that. And then we can move on to the task and we can perform actually the different actions. Now, about the authentication and authorization, I want to speak about this, is what we have seen is different users or developers, they use to pass the tokens from one agent to another in order to authenticate them. I don't recommend that at all. It is not secure at all, right? Second option is to re-authenticate the user every time that uses a new specialized remote agent. That again, this is quite annoying for the user because every time you need to authenticate yourself. What I see in the future coming is something like a central agent authorization authority that you will have all the agents communicating with that, storing all the details of the users, what agents we have authenticated already. You don't need to do that multiple times. Everything will be stored in secret managers. You don't need to exchange tokens. And more or less, this authority will play the role of agent police, if I may say, right? Like a gatekeeper in order to be able to perform everything with a very secure way. Now, from A2A perspective also, the users, they can use extensions, is a capability that we have over there, that they can implement any security measure they prefer. And on top of that, they can augment that with guardrails as well. Ilya?
Yeah, I wanted to add that we need to think about A2A as a protocol that stands on the top of an existing foundation. Yeah, so you don't need to just use A2A to solve everything end to end. You can leverage existing practices that are common to other solutions like a microservices network. For example, if you think about agents as part of a microservice, you will think about API gateways, access tokens, API keys as a way to enforce authentication and authorization, or doing things like rate limiting to ensure traffic only reaches the runtime of the agent when it passes a set of verification. This is done by design so that we avoid to reinvent every security practice on A2A, and we actually build on the top of existing things. So you can use a battle-tested infrastructure like Google Cloud to actually build this kind of skills and capabilities.
One quick call out, like in the last few days, this sounds like an amazing idea to look into, kind of like a secure MCP for agents for your capstone project. So we'll be evaluating the novelty of these. So those of you listening, might be an idea for you.
Yes. And also last week, I think we announced in Vertex AI, the agent builder capabilities, which has some inbuilt of this. So I think when you're looking at Capstone, like these are the hints which you have to be able to build for yourself. So thank you, Elia and Socrates. On to our next question for Will and Socrates from Daniel Forberg. In a system of autonomous generative agent swarms, how can we limit their operational scope and assign accountability for undesirable outcomes, including A2A actions?
Well, first off, thanks for the question. And it's interesting because I think it goes back to the last question a little bit, and that is in many ways, we're going to see the principles of zero trust security show up for agents. And meaning it's not just going to be, your agent isn't just going to inherit permissions from a business function or individual that they're representing in a transaction. So it's going to be layers of identity, authorization, and telemetry on a task by task and system by system basis. There are things that are out there to help all of you with this. Maybe like agent identity and agent registries are a great place to start because that'll give you like these initial guardrails. And eventually it'll evolve into things like risk management and policies as code or instructions for your orchestrator agents. Because again, as you start getting multiple agents executing more and more complex workflows, you're going to have this kind of orchestrator agent. You're going to have these sub agents that Saurabh was talking about earlier. And, you're going to want to be able to, inculcate those agents with the policies that you have and kind of the trust policies that you have within an organization. And what I see is, and also, we're just talking about cloudy patterns. We're going to see cloudy patterns all over again. So, applying zero trust inside of an organization, we use simple cybersecurity principles, and you could stratify trust tiers, for agents. So you could have agents that exist in different trust tiers. Just like today, we have people and or systems that operate in different trust tiers within any given organization based on their inherent risk and based on telemetry and based on like what certificates or what authentication they're carrying with them. And also patterns that, we're in such early days, like we don't really even know really, in most cases how these large multi-agent swarms are going to be operating within, one organization or across organizations. So there's a lot to build around the kind of signature of agents. And, a lot of the things that we described earlier in terms of, like tracing and sessions and the telemetry and the places where you can identify what's happening between agents and individuals. That's all going to be the fuel for developing kind of these patterns and these tiers of trust. And I also think we're going to end up kind of where we are in autonomous vehicles, which we're going to categorize the risk and the permissions of agentic systems kind of in these tiers like we do today in levels of autonomy in autonomous vehicles. So, plenty of things to get started in terms of collecting the data and inculcating, kind of these sub-agents with forms of trust. But eventually the organization is going to have to define for themselves how they feel about, these trust tiers and how they're going to free up agent workflows along those trust tiers.
From my side, I want to elaborate on what Will said, because I totally agree with him. First of all, we need to reduce the scope, we said, right? How we can do the operational scope of these agents. Agent registry, agent identity, auditability. You mentioned that already, Will. In agent registry, we will store all the different agent cards, all the different capabilities of all the different agents. But that does not mean that all the applications, they need to use the complete set of agents. Probably we need to store over there, this application has access only to those agents, for example. Then after we have reduced the scope of the number of agents we can use, is about agent identity, that we reduce the resources that these agents can use, or who is the user that can use this agent. And of course, along this journey, we need to follow the footprints of the agents and to record everything for auditability purpose. But on the other side, we can imagine the swarm of agents, or we can parallelize them with the real communities or real corporate environments that at some point you have managers, directors, or ICs, and more or less you apply the divide and conquer. What I mean is you can have small teams that they will operate only specific tasks with specific goals. You can assess them with specific KPIs. So we will see agents like managers, reviewers, approvers, auditors, that they will start planning and performing tasks. I have seen already customers implementing this hierarchical model. For example, I have seen customers that they build planners before they execute something. They said, okay, I want to run this task. Who is the right agent to call this and that? Okay, the plan that I set, first I will call this agent, then that agent, etc. And then they give that to the agents. Then a reviewer assess if this plan was executed correctly, and then an optimizer takes this plan and optimizes that for later on. Of course, even if we have a swarm of agents that they can work completely autonomous, automatic, we cannot forget that agents have been created for humans. That means that human in the loop is critical. We need always to have someone for critical decisions in the loop in order to say, yes, I approve that. With that way, also, you know that the human is accountable, at least for some critical decisions.
Yeah, it's, just one more thing too, as you mentioned, kind of the architecture of how this is going to emerge. My belief is that organizations as a whole are going to be more secure. And that's because for the first time, they're going to have to actually, deliver policies, or that, there's a lot of inside of most organizations, there's a lot of like stated policies, and then there's like the way things actually work. But in order to give instructions to agents sufficient for them to execute tasks, you have to be very specific. This is back to sort of like you have to, fine grain specific, very particular things. And in many organizations, they use humans as kind of the interstitial fluid between, the policies that they have and what actually happens in the real world. And so as more of these policies come to light, or the kind of hidden policies of an organization come to light because they're being written into software, generally it's going to raise the security level of every organization. So agents as a path to improving security.
Yeah.
Thank you so much, Will and Socrates. Like, as you all were walking through, I felt like flashy demos are easy, right? Anyone be able to create it. But these hard things, which, as you all were mentioning, eval, security, governance, risk, compliance, all of the things are what is going to make a difference when you are positioning yourself as an expert. So thank you. So this question is from Archie6170. How are safe degradation strategies defined for a partially unavailable Vertex AI agent engine agent, focusing on real-time adaptation by peer agents, task rerouting, and dynamic capability downgrades?
Perfect, Kanch. It's a great question. I'll try to unpack it, actually, because I see two common themes here, two common asks when building multi-agent systems. The first one is the need for control, and the second one is the ability of an agent or a system of agents to be resilient. So on the first one, we want to avoid those echo chambers, right, where you have multiple agents interacting together and potentially taking wrong assumption and going on a tangent on these assumptions, like in echo chambers. There are some practices to mitigate this, which you can put in place. First of all, you can adopt a supervisor pattern, where you have a central agent capable of monitoring the conversational flow, interrupting and cutting potential loops. You can also adopt a separate, totally independent critic agent that is capable of inject itself and dedicated solely at verifying facts, potentially even using code execution as a way to do it if the use case allows it. I would also consider model diversity. So potentially considering using a larger or a different model for these critical steps compared to the rest of the systems. For example, you might have for a part of the system Gemini Flash, and for the supervisor, Gemini Pro. This prevents share bias because it's not the same model making decisions, so that the supervisor is not really blindly agreeing with the workers. On the second one, which is the ability to be resilient, so the ability of have certain degradation strategies. The real question is, if one agent is down and I'm using A2A to have a mesh of agents, how do we adapt from it? So really, I would say the goal there is still provide value to the end user, even in the case of failure. Of course, like a common practice will be implement a strong retrying system. For example, you might want to consider exponential backoff so that we keep retrying even if the agent, if the remote agent is failing. But then you can also consider rerouting. So the idea that you might want to back off to a generalist agent that can answer some of the question. It might not be as deep as the agent that is failing, but you can still provide value to the end user. I would also consider a transparent UX. That means that for critical actions, imagine you have a sub-agent which has the only task of booking a flight, and that agent fails. You don't want to back off to a generalist agent to book the flight. You might want to be transparent with the end user and say, the flight is not possible at the moment to book for a flight, but I provided you an itinerary. If you want, you can book it. Here are the instructions. So depending on the UX, you can and the product that you're building, you can adapt some of it. And so the idea is really to give this partial fulfillment of your task, where even if one agent fails and 3 others are completely, you can still provide value to the end user by partially fulfilling the request.
Yeah, and I would refer back to the assignment which was there, where I think there are references to when you are defining the agent, be clear with their error messages which are there and failure patterns. Don't just silently fail. Basically, let's say you have a sub agent which is talking about a particular task. Let's say due to whatever reasons the service is not available, and you are calling and it is giving a 429 or a 503, etc. Give nice responses so that the other agents can adjust around themselves. They know what is the reason for the failure, and through that they can educate the user and can bubble up those messages or the failure patterns which are there. This actually, I would say, because of the natural language capability of the agents, these systems can be a lot more resilient than traditional software systems, where any code path, if it fails, it like everything just breaks because you assume perfect responses, etc. Here there is a chances of, and thank you for a very deep question, like really appreciate it. Like the chances of recovery is a lot higher with reasonable outputs for the end user.
Amazing. And just one quick thing to add on to that, when we talk about agents supervising and figuring out failure modes, etc., let's not forget humans in all of this, because there are also ADK offers ways to do long-running forking of control flows to humans, so some kind of risk management to see when it's become too messy for agents to figure out. Fork it to a human to make that decision. Yes.
I'm actually thinking Will's comment too, with respect to agents, the coding agents building themselves so that figure out the optimized way of answering this. Sometimes, maybe in the future, I don't know if it's there yet, but maybe in the future, there would be a agent that gets created that solves the problem and then kills it by itself. So it would be interesting to see.
Ephemeral software development, agents by agents.
Agents by agents.
Buckle up.
Automatic automation.
We have been doing well on the tagline for the classes, so for the sessions, and I think this would be one which we really look forward to. The next question is, the last question is for Saurabh from Chumban Bokche. Agents can take different reasoning paths, making cost unpredictable. What architectural strategies or hardware optimizations do you recommend to keep agent latency and cost stable at scale in production workloads?
Yeah, I think this very well connects with our earlier question as well, right? So I would say if you look from an end user perspective, there are a few strategies that you can use to control cost as well as token length, etc., because it may make some of the applications infeasible, right? If the latency is very, very large. The very first one, and we still see a lot of people not even being aware of it, is prompt caching. As you might have been writing agents, you might have been seeing that the length of the prompts keeps also increasing because you have all these different conditions that are there that you need to capture. You need to describe the tools. You need to do it in a lot more detail. We just talked about error messages. You need to explain that as well to the model. Most of all large language model providers, right, including Vertex as well as others, provide prompt caching, where a repeated prompt which is being sent to the model again and again and again, you don't need to recompute it. That has two advantages, actually three advantages. Like one is your costs go down because we are caching and you are not computing it, right? The latency is better, right? And even to a certain extent, predictability or uncertainty, etc., like that also goes down as well. The second one I would say is relating to model routing, and I think there were some other we alluded to it. I think maybe Socrates was mentioning it, that depending upon the level of task or the complexity of the task, you may have a pro model for very, very sophisticated top-level orchestrator versus a much more simpler, like a flashlight even, that you can use Gemini flashlight for very pointed tasks, right? Like as an example, like the case that we often discuss internally is if a user is saying hello, you don't need like, I don't know, a trillion parameter model to go decide what's the response over there, right? So those type of things. And then the third one, which is a little bit more sophisticated, is the constraint sampling piece, where if you have outputs that you think are within a particular domain, and I think maybe Will was mentioning about it, that we could instruct the model to sample only from that space instead of generating everything in natural language, etc. And so that can also improve both performance, lower cost, improve quality, all the benefits that you can imagine. Now on the hardware side, That is, I would say, a lot more involved. That is where there are techniques like KV caching, which is there to improve performance. That's how we can expose the prompt caching aspect to our users, and there are some other optimizations that we do under the hood. There's also speculative decoding to make things faster, as well as quantization is a very, very strong mechanism through which, instead of using, well, right now we don't use like 64 bits or 32. Most of the development is on like 16-ish bits, then 8, then 4, etc., and so on. So those also improve efficiency because you have fewer bits to process, etc. So.
And if I can add one more thing, also guardrails is very important to stop the interaction as soon as possible. You find something. ADK probably, Saurabh, you saw that in codelabs that you already run, right? We have codelabs. We have callbacks before and after calling an agent, before and after calling a model, before and after calling a tool. You can set over there guardrails and to stop immediately the interaction.
Exactly.
We have in ADK plugins that you can set these guardrails across all your agents. And of course, you can link everything with Model Armor. And immediately, if something is relevant, you can say, no, I cannot answer this question, for example.
Exactly.
And just to elaborate, technologies that Saurabh mentioned, things like speculative decoding, prefix caching, etc. This is covered in the first white paper foundational models of our previous iterations of the course. For those of you watching, please go have a look. It's and we will also attach it in the description of the YouTube link. All right, Kanch?
Thank you. So one of the things which the community really loves is also to understand what are your thoughts of where everything is going. Like, we have had incredible discussion, but I would love to hear final thoughts of what you want to say to the community. Why don't you start ahead, Bill?
Sure. Well, as you can tell, probably from this discussion and probably from the last 5 days, it's early days. And all of us here, building technology for all of you, we're really depending on you rolling your sleeves up and, exposing where things are working well and where things aren't working well. So your engagement this week, your learning, your interaction, your feedback to us is absolutely critical. Saurabh and the team are creating incredible technology at incredible scale, and there's lots more to do. So my final thought is, please continue exploring the rapidly emergent capabilities of, cloud and AI and Vertex and agent platforms, and get your feedback back to us, because that's how we're learning. As Saurabh mentioned earlier, he's got his sleeves rolled up this week. He's debugging for his son. He's blowing stuff away with the delete button. So we're all doing it. And we're counting on you to really, give us those insights that are going to make our products better and better over time. So thanks for your engagement.
Thank you, Will.
They'll be talking about insights and feedback. We'll be rolling out the post-course survey right after this, so before the capstone. So please give us your insights there so we can improve the future iterations of this course and see what you liked as well. Yeah.
Socrates, why don't you go next?
What we will see in the future? Actually, 3 areas. Make everything simpler to go to production. We are not there yet. Second is ethics and legal aspect of things. We need to consider, we need to create some regulations. It is very important. Nobody talks about, or we have started talking about this. And the last thing is live agents. We will see all these multimodality live agents. We will see new ways of interacting with computers. Probably we know now we have the computer use, for example, you can control your computer with agents, but probably in the future we might not need computers at all. We might speak in a speaker and we can do everything that we need, right?
Yes, and I know you, Heiko also has a demo. Maybe we could add it to the live agent with computer use that has been very popular. Yes. Elia, why don't you go next?
Well, future is difficult to predict, but I will say that we will see more and more agents becoming an amplifier for the value each one of us is delivering. And I would say, if I have a suggestion, please start adopting your agents. What I mean is really invest time into developing or using agents that can enhance your productivity, because it's something I personally did for a long time, and really I can see, like myself, looking back in like a year, my productivity has increased. So I will see that more and more and more. On the pragmatical part of it, I will say read the white paper, because we provide a step-by-step kind of execution how you can build and deploy agents to production. You don't have to start with the full-blown picture. Start simple and iterate over time.
I love it. Last but not least, Saurabh.
Yeah, I would plus one to Ilya, what he said, and I will emphasize on the learning part. The field is moving extremely fast. And actually, it is a good learning opportunity for all of us. Like what agents can do today, even if I think we had references about, like, for example, the ADK. We added a lot of new features even just last week. Agent engine capabilities, we added core capabilities. The AP2, the agents payment protocol, which we believe is critical for the success of agents in the real marketplace that Will was mentioning. Like all of these things have happened. There are more things that will happen in future as well. And I would say to be very abreast with like whatever is the latest technology, so that you can absorb it into highly functioning agents which can go into production. And as Ilya was mentioning, it can also help your productivity, the productivity of your organization, and whatever is the workplace. Like super exciting time to be here in this particular field. And again, thank you all as well for participating as part of this journey. And this is a learning for all of us together.
I do have to say though, when you said learning, like all of us have blind spots, in my opinion. We all think, oh, I'm sure you all have been doing this for a long time. But even for simple things, going from AI first to AI native is so important. Like the folks might not know, Saurabh, we have the Cloud AI for AI sessions. Just that, learning what others are doing and incorporating that in our day-to-day life has been really impressive. So I think all of us need to bring a curiosity for us to be able to build. So thank you so much. Despite your busy schedules, being here, answering questions, sharing your thoughts, it has been a really great to hear all of your viewpoints. Particularly, most of us talk about flashy things, but you talked about the challenges of how the enterprises or everyone would be going through, and then how we help try solving them and breaking down into smaller pieces and adopting it, and having sort of try it and then sharing the concerns. All of this has been really amazing. So thank you so much for being here, for being part of the journey, and for also the support. We have had this crew who have been going through these challenges. So this is real life experience. So thank you so much. Appreciate it.
Thanks everyone for joining.
Thank you.
Honored to be here.
Thank you.
Bye.
Thank you all.
Thanks.
Bye-bye.
This has been amazing. And now on to our next session. So we have 3 more segments. We have the code labs as normal, and then pop quiz coming. And then the last thing, exciting thing, which we have Brenda coming in with the capstone announcement. Code labs, can we have Lakshmi on stage, please? Hi, Lakshmi.
Hey, Kanch.
You're back?
Hey, Kanch. Yes, back to day 5. Hello, Anand. Good. Okay. And what an incredible week it has been. And we are on day 5, right? So for day 5, we have 2 notebooks. We start with agent-to-agent communication and then end the day with deploying agents to production. So as we start, first, I want to give a shout out to Lavi, my colleague, who is the author of this notebook. Thank you so much, Lavi. Now let's get started. Right? So as you build agents, you find that a single agent is very difficult to handle all the functionality that you have. So as you build complicated scenarios, you will need a multi-agent architecture. You will need specialist agents who are experts in one specific area. But how can you do that? So you might think, okay, I will have a root agent, and then I will have multiple sub-agents who are experts. But real life is not so simple. You might want to use agents which are built by other teams in your organization. Or you might want to use agents which are built by another organization. Cool, awesome. But how do you make sure that these two agents can communicate with each other? Because they might have been built in a different language, or they might have been built using different frameworks. And more importantly, they might be running in two different networks, right? Or servers. So you need a standard for these agents to communicate. And that's where the A2A or agent to agent protocol comes in. It is a standard for cross framework, cross language, cross organization agents to communicate with each other. Right? So, what does all of this mean when you're building an agent? So, let's kind of dive a little deeper. So, what I'm trying to do today is to build a customer support agent. And this agent will interact with the user and answer questions about a product. Like you ask about a specific product, it will give you its price, what are the features of that product, and also the availability. Cool, awesome. But there is a problem. You do not have the data of the products. This data is with your vendor, right? So the vendor owns the products and he has all the details of the product. So how do you make this work? One, you could try asking the vendor for the data, but that's not a practical solution because there are different organizations who own the data. So what can I do here? So I went and spoke to the vendor, and they said that they already have an agent called a product catalog agent, which does exactly this, answer questions about the product. Awesome. So we already have an agent, and I already have a customer support agent. So, but the product catalog agent is running in the vendor's network. So how can I access it? So the vendor tells me that the product catalog agent is A2A compatible and customer support agent can talk to that. So what exactly does this mean when you say that it's A2A compatible? So, and more importantly, how will the customer support agent know what the product catalog agent does and how to call it? So these are the two questions that we need to solve for. So when you say that an agent is A2A compatible, what it means is that it is exposing something called a agent card. Think of it as your business card, right? So this is the example of a product catalog agent card. And here the agent is giving a description of itself, and it says that my name is a product catalog agent and this is my description. And it also talks about the tool it has, which is the get product info. And the customer service agent can access this product catalog agent and then get this information. And how can it access that? So since it's A2A compatible, it has been deployed onto a URL. So in this case, we are for this notebook, we have deployed it locally, and hence you will see a URL like localhost. But in reality, this could be the the server in your organization where you are running it. So this makes sure that there's a way for your agent to be called by other agents, and also this agent card explains everything that you need to know about the product catalog agent. So if I take a step back, here there are actually two problems, right? Or two parts here. One, how do you build an agent and make it A2A compatible so that all the other agents can access it? So that's the first part. And the second part is, okay, there is an agent out there, and how do I access it? So let's kind of look at the first part now. How do you create the product catalog agent? So you create an agent as you've done over the last 4 days. And that's get product info is the tool which takes the product catalog and returns the results to the user. And then to make it A2A compatible, is extremely easy if you are using ADK. So if I kind of get into the technical aspect of it, it's as simple as making one function call, right? So you have built an agent and you're converting it into a A2A compatible agent by saying the port at which it needs to run and specifying the name of the agent. So that's all you need to provide, and you have an agent. And when you kind of use this function is when the agent card gets created. And this agent card would always be available as dot well-known slash agent card dot JSON, which you can access it. And in our case, this is on localhost since this is for a notebook. Awesome. So this product catalog agent is all ready, and then we just need to call it. And how can we do it? So at our end, we have a customer service agent. And this agent can have, sorry, let me just go here. Yeah, so this is the customer support agent. And then how do you make sure that it can access the product catalog agent? So create a sub agent, right? So, and the sub agent here is called the remote product catalog agent. And if you look at the remote product catalog agent, it's a little different from the sub agents that you have created before, in the sense that this is a remote A2A agent. And again, like any other agent, it has a name and it has a description, right? And it also has another field, which is the agent card. And what we need to do is point it to the other agent that you want to call. In this case, it is the product catalog agent, which is running in a local host, right? So that is how simple this entire part is. So if you kind of scroll down in this notebook, we have put in some scenarios for testing the A2A communication, right? So there are a few queries like, can you tell me about iPhone 15 Pro? Is it in stock? And then what is actually happening behind the scenes is that our customer support agent gets this query, it passes it on to the sub agent, which is actually a proxy for the remote A2A agent. And this agent will go and fetch the information from the catalog and return it back to the customer support agent, which then responds to the user. So that's how the flow is going to be, right? And that brings us to the end of this notebook, but there is a whole lot of information out here. The documents that you can read to understand A2A better, the sample code you can access, and all of that, right? So also, I strongly encourage you to try out a few of these ideas. Try adding an inventory agent or try adding a shipping agent and see how it goes and let us know. And with that, I move on to my next notebook, which is on agent deployment. So let me just share the tab. Okay, cool. So you have built agents, but it's all in your notebooks, right? And if you kind of stop the session, then you cannot access it anymore. So that's one. Plus, since it's in your system, nobody else outside other than you will be able to access it. So how do we solve for this, right? So the way to solve for this is to deploy it. And today we'll be talking about deploying an agent on GCP. So if you already have a GCP account, you can use the GCP project to deploy on it. But in case you don't have, you can sign up for a free Google Cloud account. So there's a link in this notebook on how to sign up. And when you sign up, you will get $300 in free credits. And this is valid for 90 days. When you sign up, you will be asked to provide your credit card details, but that's a form of verification. You're not going to be charged. And then once this $300 of credit is over, or the 90 days is over, whichever is earlier, then you will not be charged until you explicitly upgrade. And also the demo in this notebook, this stays within the free tier of the agent engine. So I'll talk more about it as we come. And there are a lot of links to the videos and the documents in this notebook. So make sure that you kind of read them and watch this video. Awesome. So let's kind of go back to a very simple agent. So today we are going to have a weather agent, right? So what this weather agent does is it calls a function and it will kind of return to you the temperature in different cities, right? So you have a couple of cities listed out here. Okay, awesome. So you do have the agent, and the next step is deployment. So ADK supports multiple deployment platforms. In this notebook, you will be deploying to the Vertex AI agent engine. And Vertex AI agent engine is a fully managed service specifically for AI agents. It's easy to deploy, and it has built-in auto-scaling and session management. And then if you want to read more about agent engine, understand what it is, there's a documentation out here. Also, agent engine offers a monthly free tier, at the rates of which is again available in this documentation. You can also deploy your agent on Cloud Run or on Kubernetes engine. Cool, awesome. So we need to have some configuration again for these deployment. And so that's what we are setting in the config file. And once that is done, we are ready to deploy. So agent engine is available in multiple regions. And for the purpose of this notebook, since we are deploying a very simple agent, we are randomly going to choose one of the agents. But when you're going to deploy it in production, there are a couple of things that I want you to keep in mind. One, choose a region which is close to your users for lower latency numbers. And then again, some of the companies might have some requirements with regard to the data, right? So which again relates to what are the policies and other requirements. So make sure that you follow all of these requirements when you choose a region. So we have done all the settings, and all that is remaining now is to deploy the agent. And with ADK, it is a simple one-step deployment. So it's as simple as ADK deploy agent engine. And then you kind of give the name of the agent that you have created, which is like sample agent in this case. So when you kind of run the step, it takes around 3 to 5 minutes for it to complete. So please wait while it is completed. So you'll kind of see all the logs while it is being deployed. And once it's deployed, you will get a resource name of this format. So awesome, your agent is deployed. So what's the next step? The next step is to query it so that you get a response. So in this case, what our query is, what is the weather in Tokyo? So what is happening over here is this query is basically a query to the remote agent, right? Or the agent which is now running not locally, but which is kind of deployed. And then you get a response. Awesome. So here, throughout the week, we kind of talked about sessions, we talked about memory, right? And then in today's notebook, we have used an in-memory session. So what happens is that when you kind of log out and when you, close the session, all the conversation until then is forgotten by the agent. But suppose, you want to know, say, for example, you ask the weather about Tokyo. Suppose you want the agent to remember what you conversed with it in the previous session. What you can do is you can use a memory bank. So memory bank gives your agent long-term memory, right? So irrespective of the number of sessions you have, it kind of saves that information. And suppose I kind of, ended that session and I kind of start another session, and then I ask about, okay, which city was I talking about in my previous question? And it will kind of tell you that you were talking about the weather in Tokyo. So again, there are a lot of resources that you can go and read about, and some samples that you can test out. Last but not the least, once you have used your agent engine and you have tested everything, please make sure that you delete the agent engine. So this will ensure that you will avoid incurring additional costs if you kind of just keep it running. So make sure to do that. Cool. So with that, you're ready for your production deployment. And again, there's a whole lot of documentation on ADK, on Agent Engine, on the ADK deployment practices, again, Cloud Run deployment, as well as GKE deployment. Make sure that you go through them. And with that, we come to the end of day 5. We started with simple agents. Then we talked about multi-agent architectures. We enhanced our agents with tools. We talked about context engineering. We learned about observability. We learned how to evaluate agents. And then we spoke about agent-to-agent communication using the A2A protocol. And finally, we learned how to deploy the agents that you've created into production. But this is just the beginning. I hope that you complete all the labs over here. And we are really looking forward to what you're going to build in the capstone projects. So Brenda will be explaining more to you about the capstone projects. But first, back to you, Kanch and Anand.
Thank you, Lakshmi. This was great, particularly walking through the entire course. It was really good. And I hope folks take the benefit of it, and all the documentation are right there for you to be able to explore further as well. Thank you so much for being here and walking us through the journey, Lakshmi. Appreciate it.
Thank you.
So now we are on to our favorite part of pop quiz, Anand.
Yes, get your pencils and pen ready and some popcorn as well.
Yeah.
So let's go to the pop quiz.
Yes. So before we start, should we see where in the world people are from? Can you all start typing while Anand is going with the question? Go ahead, Anand.
All right, your first question would be, what is evaluation gated deployment? Is it A, a process where users must rate the agent before they can use it? Kind of the thing what Saurabh talked about of having a trust reputed marketplace. Or B, a principle where no agent version reaches users without passing a comprehensive automated evaluation. Will Granis talked a lot about this today. C, a deployment strategy that only releases agents to internal evaluation teams. Or is it D, a method of manually reviewing every single agent interaction in real time? So think about that.
I see answers popping in.
Yes, your answer would be shown in 3, 2, 1, and it's B. So it's about evaluating comprehensively without before you give it to users, and that is, I think, evaluation. We have mentioned it in the previous days and emphasized a lot today. So that should ideally be part of your capstone as well. All right, moving on to the next question, shall we, Kanch? How do the A2A and MCP protocols complement each other? These are two separate things, but how do they complement? Is it with A2A is for delegating complex goals to other autonomous agents, while MCP is for standardizing connections to specific tools and resources? Or B, A2A is for connecting to databases, while MCP is for connecting to other agents? Or is it C, A2A replaces MCP in enterprise environments? Or is it D, MCP is used for remote agents, while A2A is only used for local agents? I see a lot of you have guessed the correct answer in the chat.
I can't believe how you come up with these answers. Thank you.
Really good. Happy to see that you're reading in detail, and hopefully it helps you understand the course even better. So the answer is A. Yes, that's right. A2A is for autonomous agents, while MCP is for tools. Moving on to the next question. Which safe rollout strategy involves running two identical production environments and switching traffic instantly between them? Your options are A, canary deployment, or B, A/B testing, or C, feature flags, or D, blue-green deployment?
You
Think
don't need
about
to even take the course. You should be able to answer this question.
exactly. Even the question kind of hints
Mention.
at the answer, but your answer will be shown in 3, 2, 1, and it's D. So blue-green
I see a lot
deployment.
of right answers.
Yeah, it's a software engineering principle. So, but this also applies, like as implied in other days, this also applies to agents because agents run as software after all. All right, let's move on to the next question. What are the 3 layers of defense in Google's secure AI framework as applied to agents? Is it A, firewalls, encryption, and identity management? Or is it B, red teaming, blue teaming, and purple teaming? Or is it C, policy definition with system instructions, guardrails, filtering, and human-in-the-loop escalation? Or D, unit testing, integration testing, and end-to-end testing? So your answer will be
We talked about this today.
yeah, in the white paper. So, and if not, you can think about what could be a possible option here. All right, let's go to the answer in 3, 2, 1. C. So, secure frameworks involves all of these guardrails, policies, humans, just to make sure that the agents do not go off rail.
And ADK lets you define many of this. Yeah.
Definitely. And that's why having a good framework, a development framework like ADK is super important for your production workloads. All right, let's move on to the final question for the day and the course.
Yes.
All right, everybody. So get all of you, I would like you to think about it, like assemble and think about this question. You've got to get this one right. In the observe, act, evolve operational loop, what is the purpose of the evolve phase? Is it A, to real-time triage security threats using circuit breakers? Or is it B, to use insights from production data to update evaluation datasets and then permanently improve the agent's architecture or logic? Or is it C, to monitor dashboards for latency spikes? Or is it D, to automatically scale the agent's infrastructure based on load?
I see a lot of wrong answers.
And this one should be straightforward as well, everyone. For example, option number D is should be suspicious to you, but like doesn't fit into the logic. But your correct answer is B, because B is where you evolve the agent's logic and architecture to match what it needs to do. All right, that would conclude our pop quiz. And Brenda, would you like to come on stage?
Yes, this is the most exciting thing, Brenda. I think everyone has been asking for it.
Hey folks, I'm Brenda from the Kaggle team, and I'm so excited to get to announce the details of our capstone project on Kaggle. This is your chance to take what you've learned and put it into practice. In this final project, you will be called upon to build an AI agent. We have 4 categories you can submit your project in. The first one is concierge agents, which will help solve problems that individuals have, like meal planning, shopping assistance, or calendar management. The second one is enterprise agents, which are designed around corporate problems like business workflows, data analysis, or customer management. The third track is agents for good. These are solutions for problems that humanity experiences, like challenges in healthcare, education, or sustainability. Finally, if you have a great idea that doesn't fall into one of those 3 categories, we have a freestyle track where you can exercise your creativity. We've covered a lot of concepts and technologies through the white paper, codelabs, and Q&A sessions during the live stream. We're really looking forward to seeing how you incorporate them into your final projects. A few things to keep in mind about the capstone project. Each participant could submit to only 1 track, so choose carefully. You may work individually or in a team of up to 4 people. It's completely up to you. The deadline for submitting your projects is the 1st of December, but we recommend submitting early in case any issues arise. Finally, the top 3 winning teams in each category will receive Kaggle swag and recognition on our social media channels. Every participant in the capstone will get a Kaggle badge. Now, we have heard a lot of you, including Sarab, say that you really want a certificate for your participation in the course as well. I am thrilled to let you know that we have listened, and participants in the capstone project will also get a certificate that you can share. The capstone project link will be shared with you all shortly on Kaggle Discord and an email, so keep your eyes peeled. Thank you so much.
Thank you, Brenda. That's amazing. And I know folks have been waiting for this, particularly the certificate as well. So we are looking forward to it. And I know Anand, all of us are looking forward to seeing what the capstone projects are going to be and what are the things which are coming out of it. So thank you so much for announcing this, Brenda, and really appreciate it. And thank you for all the help over the course in you are leading the effort and making things happen. Anand, we are towards the end, and we are here. Thank you. Thank you so much for being here. Of course, Anand mentioned it earlier. The post-course survey is really important because that helps us drive towards our next steps. Is there anything to add, Anand, from your end?
No, that will be all. Thanks to everyone. And I'm really looking forward to how you enjoyed it and your submissions in the capstone. And maybe stay tuned for another iteration of the
We're already ready for it
in the future. Yes. All right. Thanks, everyone.
Thank you, everyone. It was great having all of you for the last 5 days, and we really appreciate your time. Looking forward to the agentic journey. Take care.
Bye.
Thanks. Bye.